Hello and welcome to the Indoor Environmental Quality module of this Sustainable Building Training series. In this short video, you can expect to understand what indoor environmental quality and indoor air quality are, what causes indoor air quality issues in buildings, and what strategies could be employed to mitigate them, and how we can maintain high levels of indoor environmental quality in buildings. Indoor environmental quality, IEQ, and indoor air quality, IAQ, are related concepts and sometimes used interchangeably, but they encompass different aspects of indoor environments. Indoor environmental quality, or IEQ, is a broader term that considers not only indoor air quality, but also other important aspects such as lighting, quality of views, well-being, thermal comfort, and acoustics in buildings. Americans on average spend 90% of their life inside buildings, and there are data suggesting that the concentration of pollutants inside buildings is 2 to 5 times higher than that of pollutants outside buildings. Building indoor air quality requirements stem from the need to remove indoor pollutants, which have been shown to affect our health and productivity. Indoor air pollutants are linked with a wide range of health issues that building occupants may experience, including respiratory problems, allergies, headaches, dizziness, heart diseases, cancer, and other health issues. The occupants in buildings may also experience sick building syndrome, which refers to the condition in which people with no specific illness experience acute health and comfort issues such as dry cough, itchy skin, nausea, and other symptoms when they are inside buildings. Sick building syndrome, or SBS, is caused by inadequate ventilation and various types of contaminants in buildings. There is also a wide range of indoor pollutants. For example, volatile organic compounds, VOCs, may be emitted from products used in buildings such as furniture, carpets, paints, or cleaning supplies. Particulate matter, another type of indoor pollutant, which is a mixture of microscopic solids and aerosols suspended in the air, is caused by cooking, smoking, and burning candles. Another pollutant found in buildings is radon, which is a radioactive gas that infiltrates from soil into buildings and is linked with damage to lung tissues and lung cancer risks. Examples of other pollutants include ozone, carbon monoxide, lead, asbestos, and mold. All these pollutants come from indoor or outdoor sources. Indoor sources include building materials, products used in buildings, or indoor combustion sources such as wood heating, cooking with natural gas, and tobacco. The pollutants also come from outdoor sources that enter the building through openings and cracks in the building envelope. The most important strategy to maintain an acceptable level of indoor air quality in buildings is source control, or eliminating the indoor pollutant sources in the first place. For example, it is recommended to use low VOC or VOC-free paints, carpets, or adhesives to avoid emitting hundreds of harmful volatile organic compounds, VOCs, that otherwise will be added to our indoor environments. Using a highly airtight envelope like what is recommended in the Passive House Standard can also help prevent the entry of outdoor pollutants, in addition to avoiding heat loss through infiltration. A second important strategy is to enhance ventilation naturally or mechanically and allow for the fresh outdoor air to replace the polluted indoor air. Building codes and green building rating systems prescribe the minimum ventilation rates for different types of architectural spaces in the form of air changes per hour, ACH, or cubic feet of air per minute, CFM. Air change per hour, or ACH, is a measure of how many times the air within an architectural space is replaced with fresh air in 1 hour. In other words, It is the ratio of air volume exchanged in 1 hour to the total volume of the space. Mechanical ventilation systems, such as balanced ventilation with heat recovery, are effective in maintaining acceptable levels of comfort and indoor air quality while contributing to the energy efficiency of buildings. The experience of COVID-19 showed us how important it is to properly ventilate buildings to improve indoor air quality and prevent the spread of viruses. The third and last strategy is filtration using air filters and purifiers. Air filters are used in mechanical systems, air cleaners, and air purifiers to capture fine particles. The filtration ability of the air filters is communicated through minimum efficiency reporting value, or MERV, which measures the ability of a filter to separate out fine particles between 0.3 and 10 micrometers in size based on a scale of 1 to 20. For example, the US Passive House Standard recommends MERV 12 or higher for the filtration of the ventilation air. While indoor air quality is an important aspect of indoor environmental quality, there are other aspects such as thermal comfort and lighting that must be considered in a high-performance building with high levels of environmental indoor quality. Thermal comfort is an important aspect of IEQ and is defined by the American Society of Heating, Refrigeration, and Air Conditioning Engineers, ASHRAE, as condition of mind which expresses satisfaction with the thermal environment. Thermal comfort is subject to environmental factors including air temperature, relative humidity, air speed, and surface temperature, as well as personal factors such as clothing and activity levels. A combination of passive strategies such as natural ventilation and building orientation and active strategies such as mechanical ventilation is used to maintain thermal comfort in buildings. The underfloor air distribution system is an example of mechanical heating, cooling, and air conditioning systems capable of providing improved thermal comfort and indoor air quality in buildings. This system delivers conditioned air to the space through the floor plenum. Air is then returned to the HVAC system through return ducts. Lighting and visual comfort is also an important IEQ aspect in high-performance buildings. Building energy codes, daylighting guidelines, and green building rating systems such as LEED prescribe the specific requirements regarding lighting power density and daylight availability in buildings. The objective of these requirements is to encourage daylighting in buildings while reducing demand for electric lighting and saving energy. Finally, it is important to note that daylighting and visual comfort, along with thermal comfort and indoor air quality, have significant effects on the well-being and productivity of building occupants. There are numerous studies documenting these effects. As an example, an article published in Harvard Business Review in 2018 demonstrated that office workers ranked natural light as the top amenity in office buildings. Other studies have shown that office employees working in daylit environments reported fewer incidences of eye strain, headaches, and drowsiness. Thank you for watching this short video about indoor environmental quality in buildings, and I hope you found the information useful. Suggested readings about indoor environmental quality in buildings can be found at the end of this video. Also, please watch the other videos in this series to better understand how sustainable buildings can help reduce negative impacts on the environment while creating healthier spaces for people to live and work in.